Hello, Assalamu alaikum. My name is Kibra Tasnim and my metric nong is 2529659. I'll be discussing one of the most critical aspects of any operating system, memory management. Uh, so, to put it simply, memory management is how an OS controls and coordinates our computer's RAM. It is responsible for dynamically allocating space to programs when they need it and freeing that space up when they don't. A great way to visualize this to think of the operating system as a traffic controller, constantly deciding who gets memory how much, deciding they get when they get it. In the slide 2, we can see, so why does it matter? If we look at this comparison, the answer becomes obvious. Without effective memory management, the program would constantly crash or conflict with one another. With it, however, our program runs smoothly, memory is utilized efficiently, uh, from corrupting another, maximizing overall RAM utilization, enabling seamless multitasking, strictly controlling memory access for security boundaries. In the slide 3, we can see uh, allocation and de-allocation. Assigning blocks of memory when a process starts and cleanly freeing when it's need. Teams. Traffic. Keeping a constant eye on which parts of the memory are currently in use and which parts are free. Protection. Ensuring programs don't illegally or unauthorizedly access memory allocated to someone else. The slide 4. When under contiguous management, we have fixed and dynamic partitioning where process allocate in consecutive blocks. Move system utilize swapping to dynamically move processes in and out memory. In the slide 5, finally, let's look at closer at swapping and partitioning. Swapping is a brilliant mechanism that temporarily moves passive process from RAM into the disk storage known as swapping out, and brings it back when needed. Swapping in this lets us run more programs simultaneously than our physical RAM could normally hold. Partitioning, on the other hand, actively divide our RAM into distinct sections for active processes. This can be done via fixed partitioning with static blocks sizes or dynamic scales with flexibly based on the exact size of the incoming process. Thank you for your time. I am now open to any questions.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mukhtar Adioye, and I'm going to discuss about the topic swapping. Our table of content, we are going to talk about the definition of swapping, how swapping works, the swap in and swap out process, the advantages and the disadvantages of swapping, and we're going to give a real life scenario of what swapping. What is swapping? Swapping is a memory management technique where a process is temporarily moved out of RAM to a backing store and brought back when needed. Swapping, simply, is just a memory management technique used by operating systems to handle situations where RAM is full. So, we have the RAM, the swap space, and the scheduler. The RAM, limited fast memory where active processes run. The swap space, lower disk area acting as overflow for RAM. Scheduler, operating system components that decide which process to swap. Let's move on. The swapping process diagram. This diagram is just to give you a visual representation of how the swap-in process work. How the swapping process work. On the left-hand side, we can see the RAM, and on the right-hand side, we can see the swap space, where the RAM is swapping out to the disk, and whereas the swapping in to the RAM. Let's move on. The swapping and swap out process. The swap out process, which is from the process to the disk. The operating system detects memory shortage on higher priority process needs RAM. The scheduler selects a blocked process as the swap out candidate. Entire process address space is written to swap space on disk. RAM frames are freed and given to the requesting process, while the process control block is updated with swapped status. The swapping, which is the date to the process, swaps need CPU time again, which the operating system checks if sufficient RAM is available. If not, swaps out another process. Process image is loaded from disk back into RAM frames. Memory map and process control block are updated with new physical addresses. Processes resume execution from where it was suspended. The advantages of swapping: 1. Increased multiprogramming. More processes can reside in the system simultaneously by temporarily offloading inactive ones. Where a program is idle, the system will temporarily offload the ones that are idle. 2. Supports larger addressing space. Processes can have address space larger than physical RAM as long as the working set fits in the memory at runtime. Enables CPU scheduling. Allows the operating system to bring in higher priority processes, supporting priority-based and primitive scheduling. 5. Efficient memory utilization. 4. Efficient memory utilization. RAM is freed for active processes, reducing memory waste and improving overall system throughput. 5. Simple implementation. Conceptually straightforward compared to paging segmentation. The entire process is moved as a unit. 6. Cost-effective resource sharing. Multiple users can share limited physical memory, reducing hardware cost in multi-user environments. Let's move on. The disadvantages of swapping: high swap time overhead. Transferring an entire The disadvantages of swapping. We have these disadvantages of swapping here. 1. High swap time overhead. Transferring an entire process to from disk is time consuming, especially with large address space. 2. Trashing risk. If many processes swap simultaneously, the CPU spends more time swapping than executing. This is what we call trashing. Context switch latency. Processes waiting to be swapped in experience high latency, making real-time application infeasible. 4. Disk input-output bottleneck. Frequent swapping saturates the disk input-output bus, degrading overall system performance significantly. 5. Requires contiguous memory. Traditional swapping means contiguous free memory in RAM when swapping back in, causing fragmentation. 6. Solid-state disk. Where in modern systems, using solid-state disk as swap space, it causes excessive swapping, which degrades solid-state disk lifespan over time. And we are given a reward life scenario. The scenario: a student's laptop running multiple applications. A student, opens a program, a browser, IDE, music player, and PDF reader on a laptop with just 4 GB. The operating system must manage this application efficiently. Now, we are given steps on how this works. Low memory detected. RAM is 90% full. Browser, IDE, and music player are active. PDF reader was minimized 10 minutes ago. 2. Swap out triggered. Operating system select the PDF reader as a candidate and write instead to swap space on disk. 3. RAM freed. The 400 MB used by PDF reader is now freed, giving RAM headroom to the IDE completion task. 4. Swap in triggered. Student reopens the PDF reader. Operating system finds free RAM and reloads it from disk. This is a simple life scenario of how the swapping works. So, this is the end of my presentation. Assalamu alaikum.
Hello, Assalamu alaikum. My name is Saham Alam Shoishob. My metric number is 2529651. Now I'm going to talk about very important concept in operating system: memory partitioning. This is how our computer manages RAM so we can run multiple apps at the same time. First of all, partitioning means dividing our main memory into different sections. This is necessary because we want multiprogramming running many processes at once. It also provides protection, making sure one app doesn't accidentally overwrite the data of another app. The first type is fixed partitioning. Here the memory is divided into set sizes before the system even starts. It's very simple. However, there is a big problem. If a process is similar than the block, the extra space is wasted inside. We call it internal fragmentation. The next slide is dynamic partitioning. To solve that, we have dynamic partitioning. In this method, the computer creates partitions on the fly based on the exact size the process needs. There is no waste inside, but as program start and stop. They have small gaps in memory. Eventually, these gaps are too small for new programs. This is called external fragmentations. If we compare them, fixed partitioning is easy to make but wastes spaces. Dynamic partitioning is much more flexible, but it is harder for the OS to manage. For example, if you put 5 MB process in an 8 MB fixed block, you lose 3 MB. In dynamic, you use exactly 5 MB, but you might have leave hole later. In my opinion, both methods have pros and cons, and modern systems often use even more advanced techniques like packing to solve these fragmentation issues. Thank you.
For the next slide is fragmentation. First, what is fragmentation? One major issue in memory management is called fragmentation. Fragmentation is happen when there are unused memory space that cannot be properly utilized by the operating system. There are two main types of fragmentation. There are internal fragmentation and external fragmentation. Internal fragmentation occurs when the allocated memory is larger than the memory actually needed by a process. For example, partition size for 100 megabyte and the process use only 70 megabyte and the other 30 megabyte being wasted. On the other hand, external fragmentation happens when free memory space are scattered into many small blocks. Even if the total free memory is enough, a process may still not fit because the memory space are not continuous. One common solution is compaction. Next, this table compares swapping versus partitioning. Swapping is move process in and out of RAM, and swapping use this storage and it will improve multitasking. For partitioning, divide memory into section, and it use RAM partitions and it will organize memory allocation. Modern operating system now use more advanced techniques such as virtual memory, paging and segmentation. This method help reduce fragmentation and improve overall system performance. For the conclusion, memory management is very important in operating system. Swapping help free RAM space while partitioning organize memory allocation efficiently. Proper memory management improve system speed, stability and multitasking. I think that's all from us. Thank you and Assalamualaikum.